All right, this is Basic Skills Packet number 1, problem number 2. This one here is talking about a plant that is growing over time. So the height has been recorded and the days that it's been growing have been recorded. And we're going to do another graphical analysis on this where we plot the data, find the line of best fit, and then try and make an equation from that and use that to answer some other questions. So the first step here is plotting the data. Lots of people have come to me struggling with how to scale graphs. So on each of these problems that I do, I'm going to talk about how to scale it, and hopefully that should make more sense than after you watch these. So the first thing is identifying what are on the different axes. I said that plant height for this problem needs to go on the vertical axis, and the days of growth needs to go on the horizontal axis. So that's how we're going to set it up. Starting here with plant height on the vertical axis. It goes up to 36. Now 36, you could scale it up to 36, but I think there's a nicer number nearby that would work better, which is 40. So I would suggest you scale this so the top of the graph gets to 40 here. That's pretty close to 36, and it's nice even numbers. And then to figure out how to space things in between there, what you do is you say, all right, 40 divided by 20, because each of these graphs that I give you are going to be a 20 by 20 graphs, meaning they have 20 boxes up and down, 20 boxes left to right. And so what you do is you take the maximum value that you have and you divide it by the 20 boxes, and you get how much each box contributes. And so 40 divided by 20 is 2. So that means each of these boxes is 2. Starting here at the bottom, we always have 0 at the starting point. All right, now going up, I'm not going to mark every box because I think that gets too cluttered. But if you just think to yourself, all right, that first box is 2, and then jump up to the next one would be 4, and then we're going to skip 6 and then write 8, and then we're going to skip 10 and then write 12, all right, all the way up that way. That's how you would label that axis. And then for the days of growth, that ends at 17. Again, 17 would be kind of a bad number. It wouldn't give us a nice number of boxes. So what I'm going to do actually is say, let's say 20 boxes. 20 is the maximum value, and it's going to be covered with 20 boxes, and then you divide that and you get 1. All right, so what this means is each box here is actually just equal to 1 unit, which is really, really perfect. That means, you know, not a lot of mental effort there in terms of labeling these. Each of these tick marks is 1, so I'll skip that first one and then 2, and then skip the next one and then 4, and then skip the next one and then 6, etc., etc., etc. So I'm going to go ahead and label these right now, and then I'll continue on. The next step is to plot your data. I'm going to assume that at this point that people are pretty good at doing that. You know, just look up days of growth on the x-axis, plant height on the y-axis, and put your points in. If you're struggling with that, though, make sure you come in and talk to me. So your data should look something like this, and then I'm going to put on my line of best fit. And now I can move on to answering some of these other questions. So first question here, it says to calculate the slope. All right. So again, the strategy here is going to be to find some intersection points where it's really nice and along the line. So I'll look here. It looks like we've got a good one sort of right here where it intersects directly with the line and a sort of a crossroads of the x and y. I'll try and find one down lower on, because the further away we can get, the better. It looks like this is pretty close right here, so we'll use that point there. And so I just figured out what these 2 points are. What I've got here is I've got 9, 20 as one of my points, so I'll write that down, 9, 20. All right, and then as my other point that I've got there, that looks like it is 16, 34. And then I do a rise over run on this. So the rise there, it went up by 14, or delta y over delta x. Went up by 14 in the y, and then with the x's, it went up by 7. So that's really nice there. 14 divided by 7 just equals 2. All right. And that means my slope would be 2. Now thinking here of the units, y is in centimeters, x is in days. So our slope should be 2 centimeters per day. Thinking of a common sense interpretation of that, 2 centimeters per day, centimeters would be how much, 2 centimeters is how much it's growing, and then per day means each day. So each day our plant grows by 2 centimeters. That's a good common sense interpretation of that. Moving on here to the vertical intercept. All I do with the vertical intercept is look and see where it is hit on the graph. If I look here, I see that that looks like it's, sort of between 0 and 2, so maybe like just about 1, and so I would call the vertical intercept here 1. All right. And then the units on that, since it's on the vertical axis, we look at the units on the vertical axis, that's centimeters on the y. So 1 centimeter is the units. And then the interpretation of that, it's going to be the plant's height at 0 days, or the initial height of the plant, or something along those lines. So that would be a good interpretation there. All right, so now we'll use this information to go on and complete the next page. So it says to create an equation demonstrating this relationship. So what we've got here is we've got the height of the plant on the y-axis. You start with y equals mx plus b. But then you just put in the things that we found. So the variable, the y variable in this case, is going to be the height. So I'll leave that as h equals, the slope we had was 2. The x variable I'm going to put as t for time, number of days that it grows, and plus 1 for the y-intercept. All right, and then I make my little key here. I say h equals the height, and you have to remember to put the centimeters here on, so that people know what the units are. And then the t is equal to the days of growth. Right. Alternatively, you could have used D there and used D as days of growth. I think T is a little bit more normal because T is typically used for time, but it's up to you on that one. So it says use this equation to predict the height of the plant after 100 days. So we're just going to plug in values here. What they've given us is the time, or the days of growth. So H is going to equal 2 times 100 plus 1. And if you go through and calculate that, you should get 201. And since we're calculating height, it should be in centimeters. 201 centimeters. All right, next, it says to graph this again. And so we're going to use the same scale. We're just going to flip it. So on the y-axis now, it will go up to 20. On the x-axis, it's going to go to 40, and we're going to plot the same data as before. We've just flipped the axes. So I'm going to go ahead and do that, and I'll be right back. And now I've got it all graphed here, and it asks us to find the slope again and the vertical intercept of this. So to find the slope, I need to find a couple good points where it seems to intersect or nearly intersect on the graph. Looking around here, I'll mark off the 2 points that I think look pretty good. All right, so these are the points 2, 1 and 34, 16. So I'll find the slope from those. 2, 1 and 34, 16. I do a rise or a run there. So the change in y in that, it looks like it is 15. the change in x, it goes from 2 to 34, so that is 32. All right. If I put that in my calculator, I get 0.47. And then the units on that, because we're going to go y units over x units, it's going to be days per centimeter. An interpretation of that, even though I didn't ask you for that in this case, would be that it takes about half a day to grow 1 centimeter. All right, so that's the meaning of that slope. The y-intercept you can see here looks like it's right about 0 or negative 0.5 or something along those lines. So I'll call that, we'll say our vertical intercept. Is about negative 0.5 there. And then in this case, since we're looking at the y-axis, that would be days. All right. This would be the days of growth for when the plant was 0 centimeters tall, or it would indicate that it was 0 centimeters tall about 0.5 days before we started observing the plant, or something like that. Now it asks, what's the relationship between the slope of the first and second graph, and what are the relationship between the intercepts? Well, what happens here is that the slopes are reciprocals of one another because we have days per centimeter versus centimeters per day. And the y-intercepts are actually not related at all. One of them is in centimeters, one of them is in days. So one of them means it's the plant height at 0 days, and the other one was the number of days that would have gone by when the plant was at 0 height. The intercepts aren't really related, but the slopes are reciprocals of one another, so that's how that works. If you come across something like this in the future, hopefully you'll be able to figure that out. Especially this comes up sometimes when people plot the wrong variable on the wrong axis and they don't want to do all of their work again. They can realize that the slopes are reciprocals. And then something else that's sort of interesting, the y-intercept on one graph here is the x-intercept on the other graph. So that at least, if you can look back there and figure that out, that might help you out. But the two y-intercepts, or the two vertical intercepts, are not themselves related. All right, moving on to problem number 3 here. In this one, what we have is a person whose job it is to fill up gasoline tanks at a gas station. And so what this person's trying to do is make the process more efficient by figuring out how long it would take for him or her to fill a tank. And so we've got some data collected here, and we're going to go ahead and graph that data. It says here that we should be putting time on the x-axis and volume on the y-axis. So that is what we'll be doing. So first thing here, got to think about the way that we're going to scale this graph. Volume here, it goes up to 6,700. So that's just about near 7,000, I think is a nice round number near there. So we'll scale this side to 7,000. So we take 7,000 and we divide it again by our 20 boxes. All right, 7,000 divided by 20 gives you 350. All right, and then thinking about the time goes up to 27, all right, which is just about 30, I would say. So for the time axis, we're going to say 30 divided by 20, which gives you 1.5 there. And so when we label these, we're going to have this is 0, 0 there. And then on the y-axis, each box is 350. Or if we skip the first box, we go 350 and then 700. And then we're going to skip the next box again. So skipping 1050, and then we get 1400. All right. And then so on on that one. For the x-axis, each box is 1.5. So we've got 1.5 for the first box, and then 3, and then 4.5, and then 6. And so on that way. So I'll go ahead and label all of those and plot the points and put the line of best fit on there, and then we'll go from there. And next I need to find a couple places here where it crosses at nice intersections. So I see this looks like a nice intersection there, and this here looks like a nice intersection. So I'll use those for my data points. All right, and those points are 4.5, 2450, and 22.5, 5950. All right, so we'll take these points now that we got here, and we'll use them to calculate our slope. First of all, we've got our rise there going 2450 to 5950. That's going up by 3,500. All right, and going up 4.5 to 22.5. That is going up by 18. So we're going to go ahead and calculate what that would be really quick. I get there about 194. And then, since this is the slope, we've got y units over x units. All right, so that is gallons per minute. All right. And then, as an interpretation for this, this is how fast he fills the tank. All right, so you fill the tank by 194 gallons each minute. Going on to the back page is going to ask us to find the vertical intercept. So if we look back up here, I see that my vertical intercept is just above 1400, maybe call that 1450. All right, so on this one, our vertical intercept is 1450. And the units on that, since it's on the vertical axis there, are going to be gallons. And I think that a good interpretation of this would be it's the number of gallons at time 0, or it's the initial volume of gasoline in the tank when you started filling it. Okay, so writing an equation here then, we'll use these two pieces of information that we've got. I'll say V for volume equals the slope, because remember we're filling in here y equals mx plus b, right? So the y variable was volume. The slope was 194 gallons per minute times our x variable, which is time, plus our intercept there, which I said was 1450. All right, and then calculating this, we're going to say, making a key for this, we're going to say V equals volume in gallons. And that T equals time in minutes. Okay, using this equation to figure out how long it's going to take to fill the tank completely. So if the tank is completely filled, if you look back on the first page, it has a volume of 8,000 gallons. So we know that our volume would be 8,000 when it's filled, just plugging into this equation that we've got there. So 8,000 is going to equal 194 times T plus 1450. We would subtract 1450 from both sides, and then divide by 194. And when I do that, I get T equals 33.8 minutes. All right, going on here. For G, it says, using either your equation or your graph or some other logical reasoning, determine what quantity of gasoline was in the tank after you had been filling it for 10 minutes. Explain how you determined this. So what we're going to do here, I think the easiest way is just to look at the graph and find 10 minutes on the graph and figure out what the volume was. So looking back at this graph here, we find 10 minutes, trace it up. So 10 minutes here is about here. All right, and then we'll trace it over. It looks like it's right about here. So it looks like right around 3,500 gallons. And we just did that by graphical inspection. All right, on to this challenge question here. It said if the tank started out full and you were to drain it and empty at the same rate it was filled in the previous question, how would the graph look? Different from it, provide a general sketch, no numbers. Okay, so what we'd have here is we'd have the same slope, but it would be the opposite in value. So generally speaking, what we'd have here is we'd have a graph that looked like this. All right, volume would be on this side, the time would be on this side, but instead we'd start here at 8,000 and it would gradually empty. All right, and then the slope here is going to be the opposite of what we had. So we had 194, so the slope would have the same magnitude, but it would be the opposite in sign. So slope would be negative 194 gallons per minute in this case, since we're taking it out instead of putting it in. All right, that is that. If you are still confused after watching this video, I will be putting a video up of the extra additional homework assignment that I put out, so you can watch those problems as well and get a little bit more practice even.